Hi guys, and welcome back to Aisha.Academy. So today's video is another past paper. This one is still the June 2017 past paper, higher one that I am doing in terms of the series at the moment. I've done paper 1, which you'll find in the link above. So yeah, let's crack on with paper 2. Okay, so just as a refresher, this one is a calculator paper. So make sure you have your Casio or whatever scientific calculator you have ready if you want to try answering these questions at home. So with the first one, it says that it's given us a table of different probabilities of it landing on numbers 1 to 6 on a dice. So it's given us the probabilities 2 to 6, but it's not given us for 1. So it wants us to estimate the number of times of the dice landing on a 1 or a 3. So we know that the probability of it landing on a 3 is 0.18, but landing on a 1, we need to work that out. So we know total probability adds up to 1. And I've got my video for probability in the link above if you want to watch that to refresh your memory. So if we know total adds up to 1, to work out the probability of it work out the probability of it landing on a 1, we need to do 1 take away 0.17, take away 0.18, take away 0.09, take away 0.15, take away 0.1. And if you were to work that out in your calculator, you would be left with an answer of 0.31. So we know that the probability of it landing on a 1 is 0.31. Then because it's to do with the total probability of it landing on a 1 or a 3, you have to add the probability of it landing on a 1 with the probability of it landing on a 3, which is 0.18, which is 0.49. So then now we've worked out the probability of it landing on a 1 or 3. But to work out the number of times, remember you always have to do your probability, multiply the total number of times, which is 200, which would be 98. And again, I have a video of this in the link above in case you need to refresh your memory on these. So moving on to question 2. So in this scenario, we've got some adults, some children in a theatre. It's given us the ratio of adults to children, and it's told us that some people are seated in the circle, but some people are seated in the stalls. So I'm going to make a table. So adults, so A for adults, C for children, we'll call that people, and then circle, stalls. So we know that 3/4 of the children are seated in stalls, and that's 117 children are in the circle. So to work out the number of children in the stalls, we need to work out, so if 3/4 of them are in the stall, that means 1/4 of them are in the circle. So to work out what 3/4 is as a value, we would have to multiply 117 by 3. And if you put that into your calculator, you would be left with an answer of 351. So now we know that how many children are in stalls. We know that the ratio of adults to children is a 5-to-2 ratio. Okay, so 5-to-2. So the total number of children is the 351 plus 117, because it's the total in the circle and in the stall, which would leave you with an answer of 468. So that is equivalent to 468. So to work out the number of adults based on this ratio, you want to divide 468 by 2. You have to work out what one part is and multiply that by 5. And again, I have a video on ratios in the link above if you want to refresh your memory on those. So if we were to put that into your calculator, divide by 2 times by 5, you should be left with 1,170 adults. So you have 1,170 adults, 468 children. Okay, so that's how many children we have, how many adults we have. Then to work out how many adults in the circles and the stalls, realistically, we wouldn't even need to do that, because if you know your total adults is 1,170, and you know that your total of children is 468, then you would have to do the 1,170 add 468, and if you were to put that into your calculator, you would end up with an answer of 1,638. So we know that 1,638 seats would be occupied. So to now work that out as a percentage, you'll do 1,638 divided by 2,600 multiplied by 100, and that would give you a percentage of 63%. So if we know 63% of the seats are occupied, that is more than 60%. So we would say yes, more than 60% of the seats are occupied. Okay, bro. So that's that question. So moving on. Okay, so question 3, we are going to be drawing this prism, but in a front elevation and side elevation. So basically, you're going to be drawing them as 2D shapes. So if we look at the front one, it said front is from this view. So yeah, circle which view we're going to be drawing in red. So it'll be that view. So then if we look, it says for every 2 centimeters is equivalent to 1 meter. So this 2 centimeters height would be equivalent to 4 centimeters. This would be equivalent to 4 centimeters as well. This small 0.5 meter height would be equivalent to 1 centimeter. So if we now draw that on, so each square, so on a centimeter grid, each square is 1 centimeter. So that would be the 4 centimeter part. That would also be the 4 centimeter part, 1 centimeter. That. So this would be the front. And then for the side view is this part here. So again, unit conversion. So this would be 2 centimeters, and this would be 1 centimeter. So then 2 centimeters, 1 centimeter. So then this would be our side. And that's basically that question. Moving on to question 4. So question 4 is to do with basically Ollie drove 56 kilometers from Liverpool to Manchester, and then it's now worked out his average speed from Liverpool to Manchester, and it's worked out his total time from Manchester to Sheffield. So I'm going to kind of draw this out. So Liverpool to Manchester to Sheffield. Okay, so from Liverpool to Manchester, the distance was 56 kilometers. From Manchester to Liverpool, it was 61 kilometers. The speed from Liverpool to Manchester was 70 kilometers per hour. And so distance, speed, and time. And then the time from Manchester to Sheffield was 75 minutes. So we need to work out his average speed from Liverpool to Sheffield. So in order to work that out, we have the total distance. So if we add 56 and 61, you would end up with a total distance of 117 kilometers per hour. Sorry, kilometers. But in terms of the total time, that's what you need to work out, because to work out his average speed, so speed is equal to distance divided by time. So to work out his average speed, we need to work out his total distance and divide that by his total time. But we only know the time from Manchester to Sheffield. We don't know the time from Liverpool to Manchester, so we can work that out. So time, to work out time, so sometimes people draw the pyramid to help them remember that. So speed, distance, time. So to work out time, it's distance over speed. So in this case, it's going to be 56 divided by 70, which is going to give us an answer of 0.8. But in minutes now, you need to times that by 60 because there's 16 minutes in an hour. So then if you multiply that, that would leave you with an answer of 48 minutes. So his total time from Liverpool to Manchester is 48. But then from Liverpool to Sheffield, add 48 and 75, and that should give you an answer of 123 minutes. But then remember, this is per hour, so we've got it in minutes. So to work out how many hours that is, we need to do 123 divided by 60, and that would give you an answer of 2.05 hours. So then we know in total of hours is 2.05. So to work out his average speed, we need to do 117 divided by 2.05. And that should give you an answer of 57.073170, so on. But to round it to three significant figures, it would be 57.1. Okay. And then if we have a look at part B, it says that Janie drove from Barnsley to York. So you're saying the average speed from Barnsley to Leeds was 80 kilometers per hour, but from Leeds to York is 60 kilometers per hour. So you're saying to work out the average speed from Barnsley to York, you can just work out the average of both, well, work out the mean of both of those speeds. So if Janie is correct, what does that tell you about the journey? Well, if Janie is correct, then what that is basically telling you is that they either must be the same time, or it must be the same distance. So that's what it's telling you. Okay, so if we have a look at question 5, so question 5 for this one, it wants us to work out the length of A to E, so this one. So this is to do with similarity of length, which I have a video in the link above. So if we look at this, it's basically where you've got a big triangle and you've got a little triangle of a similar shape within it. So I'm going to label the lengths onto this shape. So E to C was 8.1 centimeters, D to C is 5.4, D to B is 2.6. If we know that the big shape has a length of 8.1 and this one is 5.4, we need to work out the scale factor. So again, this is all in the video in the link above on similarities. So 8.1 over 5.4 would, if you put that into your calculator, would give you an answer of 1.5. So we know the scale factor is 1.5, which means if you want to work out the size of the bigger shape from lengths on the little one, you need to multiply by 1.5. And to work out the lengths on the small shape from the big one, you need to divide by 1.5. So because A to E is on the bigger shape, we would need to do 2.6 times 1.5. Put that into your calculator, you would get 3.9 centimeters. So A to C is 6.15 centimeters, and it wants us to work out the length A to B. So if we are to work out the length A to B, so this whole part is 6.15. So to work out the length from B to C, we would do 6.15 divided by 1.5, because we're working out a length on the smaller shape from the bigger one. And if you put that into your calculator, you would get 4.1. So that is 4.1. Then to work out what A to B is, you would just simply do 6.15, take away 4.1, which will leave you with 2.05. So moving on to question 6, this is on compound interest, and I have a video on compound and simple interest in the link above. So looking at this, okay, so we've got personal bank and secure bank. So Anil wants to figure out which bank he's going to need to use. So using compound interest for the personal bank, so I'll call it PB. So for the personal bank, he wants to save £25,000 in the space of 3 years. So for compound interest, one way of doing it is literally if you work out what 2% of 25,000 is, and if you used your calculator to work that out, you would get an answer of, so remember, to work out a percent of something, you do 25,000 divided by 100 times by 2, which would be 500. And then I would add that on, which would be 25,500. And then you would again, so that would give you the amount at the end of the first year. But then to work out for the second year, you would again have to work out 2% of this time, 25,500, and go on. So that is compound interest. But if that method is long for you, another way of working it out is with compound interest, 2%, if you're adding on 2% each year, you're adding 2% essentially onto 100%. So as a decimal, you're basically, that would be the same as 1.02. And then you could multiply, and because it's over 3 years, you would do the 1.02 to the power of 3 multiplied by 25,000. And if you put that all into your calculator, you should get an answer of 26,530.20. And then for Secure Bank, it's got a rate of 4.3% for the first year, but a rate of 0.9% for the extra years. So to work out the amount at the end of the first year, convert that into a decimal, which would be 1.043. So 1.043 multiplied by 25,000. It's just 1.043, no power, because that's just for 1 year, the first year, which should leave you with times 25,000, 26,075, and then you would do that 26,075 multiplied by 1.009, because that's that as a decimal, and because that's for the extra years. So because it's 3 years in total, if 1 year would be there, then it would be 2 years for that rate. So then that would be squared. And if you put that all into your calculator, that would leave you with an answer of 26,546.46. So if we have a look at those two answers, we know that at the end of the year, it's Secure Bank, where he has the most money, so that's the bank he should preferably use. Okay, so if we have a look at number 7, so number 7 basically says a number n is rounded to 2 decimal places, which is 4.76. So it wants us to write its inequality for its error interval. So what it basically means is that because it's been rounded to this 4.76, that's not its exact number. So to work out what range it could be is the lower end would be the 4.755 and the upper end would be 4.765, because that would round up and it could be anywhere up to 4.765, but not actually 4.765, because if it was 4.765, then it would round up to 4.77. So how we write this as an inequality is you would have your n in the middle. It could be equal to 4.755, but remember it cannot actually be equal to 4.765, just between that range. And then question 8 is on cumulative frequency, which I have a video on the link above. So with this question, it basically wants us to work out the number of students with a height greater than 160 centimeters. So we would draw up a line from 160 across. That is hitting at a cumulative frequency of 48. So because it's a student with a height more than 160, it's this portion of students. So because the total cumulative frequency is 60, then within that range is 60 minus 48, which is 12 students, because up to there is 48, so between there would be 12 students. So the answer would just simply be 12 students. Okay, so moving on to question 9. So here in this scenario, we basically Kyle has reflected shape A into B and C, and we need to basically see if Amy's triangle C is in the same position as Kyle's triangle C. So let's work out Kyle's triangle C first. So he reflects triangle A in the x-axis, so that would be reflected along here to get triangle B. So reflecting that would make this shape B. Then triangle B is reflected in the line y is equal to x to get triangle C. So if I draw that as a red line, so this would be y equal x. So remember, the line y equal x means that the x and the y values on each coordinate are the same. So notice here 1, 1, 2, 2, and so on. So if it's reflected along that line, so this is 2.5 squares. So that 2.5 squares would make that point there. This is 3 squares, so 3 squares diagonally would be there. and then that point is like that. So then it would end up being here. So then the points for triangle C would be there. And usually when you're reflecting, if you find at least like 2 of the other points, it makes it 10 times easier to find the rest of the points by looking at the original shape. Okay, so now we know where triangle C is. The next bit is now we need to work out Amy's reflections. So she's saying that she reflects triangle A along the line y equals x to get triangle D. So that would be here, here, here. And then she reflects triangle D along the x-axis, so along here, to get triangle E. So along the x-axis, that would end up being that point. 4 points from there would be there, and then 4 points from there would be there. So this would be triangle E. And as we can see, clearly Amy's triangle E is nowhere near triangle C. So is Amy correct? No. Okay. So question 10, as we can see, like some of the numbers in terms of like the mass and the distance, they look like they're in the format of standard form. So this would be good standard form revision, which I have a video in the link above if you want to refresh your memory on that. So cracking on with this question, it's first of all, it just says write down the name of the planet with the greatest mass. So we're looking at this column. So to help you out, it would be the number with the biggest power, essentially. So because we've only got one 10 to the 7, there's no other one with 10 to the 7, then it would just be strictly Jupiter. If you had, let's say, had another number in the mass that had a 10 to the 7 as well, then you'd have to look at both of their numbers in the front to compare which one is bigger. So yeah, that one, nice and easy. And then part B, it says find the difference between the mass of Venus and mass of Mercury. So Venus mass is here, Mercury mass is here. So that would be 4.869 times 10 to the 24 minus 3.302 times 10 to the 23. Because this is a nice calculator paper, you can just literally stick that into your calculator, and that should give you an answer of 4.5388 times 10 to the 24. Okay. And then part C, it says Nishat says that Neptune is over 100 times further away from Earth than Venus is. Is she right? So let's have a look. So Neptune is, so we know Earth, the distance from Earth to Earth is 0 as expected, but the distance from Earth to Venus is 4.14 times 10 to the 7. The distance from Neptune to Earth is 4.35 times 10 to the 9. So Neptune was a distance of 4.35 times 10 to the 9, and from Venus to Earth was 4.14 times 10 to the 7, because just remember that this column is all showing the distance of particular planets from Earth. So having a look at that, the easiest way to do this is to see whether Neptune is 100 times further away. You would do the distance from Neptune to Earth, which is 4.35 times 10 to the 9, divided by 4.14 times 10 to the 7. And that should give you an answer if you put that into your calculator of 105.07, so on, so on. And by doing that, because our answer is over 100, and the question is saying, is it over 100 times further away? Then yes, it is 100 times further away. Okay, brill. So let's have a look at question 11. So question 11, it's solving algebraic fractions. So let's have a go at this. So what we're going to do is we're going to multiply. So because we want the denominators to be the same, we're going to multiply the whole of the first fraction by 3. So that would be 3 times 3x minus 2, and then your denominator will be multiplied by 3. And we're going to multiply the whole other fraction by 4. So it would be 4 times the 2x plus 5, and then 3 times 4. The whole point of we're doing that is now we have the denominators the same, because both of the denominators are now going to be 12. And that's going to be equal to the 1 minus x over 6. But since we've changed it on the left-hand side to 12, we might as well change it on the right-hand side to 12. So to do that, that means that we need to multiply that whole fraction by 2. So that would change to 2 multiplied by the 1 minus x, and then 12. Brill. So everything in terms of the denominator is the same. So now that we've done that, these can all cancel out. And then we end up with the 3 bracket 3x minus 2 minus 4 bracket 2x plus 5 is equal to 2 bracket 1 minus x. So now we're just going to expand the brackets. So that would be 9x minus 6 minus 8x minus 20 is equal to 2 minus 2x. Simplify. So 9x minus 8x would leave you with x. Minus 6 minus 20 would leave you with minus 26 is equal to 2 minus 2x. Bring the x's to one side, bring the numbers to one side. So I'm going to move minus 2x over and the minus 26 over. So then that would be, so minus 2x brought over would be x plus 2x. Remember, if you bring it over, the sign changes. And then the minus 26 would change into plus 26. So now we've got 3x is equal to 28. And then to work out what x is, divide both sides by 3. You end up with 28 over 3. Leave it as a fraction, because if you were to now put that into your calculator, you would get a recurring decimal. So to leave it as a more accurate number, leave it as a fraction. Okay, bro. So moving on to question 12 to do with tree diagrams, so probability trees. Okay, so in this scenario, we've got 30 students in Mr. Lee's class, 16 of them are boys. 2 students from the class are chosen at random. So the first tree is showing the probability of picking out one student, whether it's a boy or girl, and the probability of picking out the second student after you've picked the first student. So this is write down one thing that is wrong with the probabilities in this probability tree. So let's have a look. So this first tree looks correct because there are 16 boys, so 16 out of 30. And so there would be 14 girls, because if you did 30, take away 16, you get 14. So I'm happy with this tree. However, let's look at the other one. So for instance, the probability of picking out a second boy after you've picked out the first boy, it wouldn't have a denominator of 30. It would have a denominator of 29. So it would be 29 over 15. 15 over 29. And the reason why is because you've already taken out one student. And so therefore, all the probabilities for the second student should all end in 29, since you've all picked out one student already. So for the girls, it'll be 14 out of 29 for that one. And then for the second tree, it should be 16 out of 29, and then it should be 13 out of 29. So really and truly, we can see that the common error is that the second student probabilities should all be out of 29, and they're not. So that's one thing wrong here. Then it says Owen and Wazim, they play for a school football team. So it's given us the probability of Owen scoring the next match and Wazim scoring the next match. So Mr. Slate is saying the probability that both boys will score a goal in the next match is 0.4 plus 0.25. So no, because again, I've got a video of probabilities basically explaining this. But remember, if you've got, there's a difference between independent probability and mutually exclusive. So in regards to this, Owen and Wazim, they can score at the same match because it's the probability of them both scoring at the next match. So the probability of them scoring. So they can both score at that next match. So because they can both score at that next match, the two probabilities can happen at the same time. And so because of that, you wouldn't add them together, you would multiply them together, because the Mr. Slater is basically working out the probability of them both scoring at the next match. So because that probability is both occurring at the same time, you would multiply them together. And if you were to put that all into your calculator, you would get 0.01. So is he right? No, because both probabilities can happen at the same time, so you would multiply. If it was a case of where they can't happen at the same time, so both Owen and Wazim cannot score in the same event, then therefore you would add them together. All right, so moving on to question 13. Question 13 is looking like a histogram question, which I should bring out a video next week on histogram. That's the plan. So let's have a look. All right, so it says we've got 134 members of the sports club. 20% of the members of the sports club are over 50 years of age for females. So it wants us to estimate the number of females who are over the age of 50 years in the sports club. Okay, so what we're going to do is we're going to add up the probability. We're going to add up the values in each bar. But actually, we don't even need to do that for this part because we're just focusing on the ones that are over the age of 50. So 50 would be here. So if we draw a line, okay, so it says 20% of them are over the age of 50. So let's look at this whole bar. So we're going to work out the number of the frequency, aka between 40 to 60. So the number of females, or the number of members, sorry, within that bar. So to do that for histograms, you would need to do the frequency density of that bar, which is 1.4 multiplied by the total number in that range, which is 20, because from 40 to 60 is 20. Put that into your calculator, you should get 28. So we know that whole bar is 28, but because we're focusing on those over the age of 50, so we're splitting it in half, that would just be 14. And then for the second bar, from 60 to 90, so we're going to end up multiplying the frequency density by 90, and the frequency density for this bar in particular is 0.7. So 0.7 times 30 would be 21. If we now add those values together, so the 21 plus the 14, because remember only half the bar, that's 35. And it says that 20% of over 50 people are female. So to work out the estimate number, we need to work out 20% of 35, which would be, if you put that into your calculator, you could just put into your calculator either 0.2 times 35, or you could do the whole 35 divided by 100 times 20. And that should give you an answer of 7. Yeah? Okay. So we know that that answer is 7. Okay, moving on to question 14. So we've got a bunch of different graphs here. I'm just zooming out so you can see the whole question. Okay, so we've got a bunch of different graphs here, and basically what it wants us to do is we need to match certain equations that they put in the table with the right graph. So let's have a look. So the first one says y equals sine x. So just to recap, trigonometry graphs for your sine, so y, x, so 90, 180, 270, 360. So remember for sine, 1 minus 1, it should go like this. It starts at 0, 0. By the time it reaches sine 90, that's equal to 1. And then it should dip. Let's draw that again. So sine 90 is at 1, sine 100 and 80 is 0. So yeah, it should be like that. Okay, so we need to look for a graph that's quite similar like that, and then on the opposite side, it will be like, sorry, bless me. It would be something like this. So we're trying to look for a graph that's quite similar to that. And to be honest, the only one that looks quite similar to the shape I've drawn is either graph D or graph C. But to know which one would be right, notice how the one that I've drawn, it crosses at 0, 0. Graph D does not do that. It crosses at a coordinate of 1, 0. So then 0, 1. So then it would be C that's correct because that's crossing at 0, 0. So that one is equal to C. And then the second one says y equals x cubed plus 4x. So we're looking for like a cubic graph. So cubic graphs, they have three turning points. Correction, they have two turning points. So we're looking for a graph with two turning points. So the one that looks like it has two turning points would be F, because it turns here and it turns here. So it turns once, it turns twice. So that's the shape of a cubic graph. So that would be F. And then we've got 2 to the power of x. So this would be an exponential graph. So we're looking for a graph that looks like exponential. Exponential graphs, just to recap, are the ones that look like they're progressively going. So then that would be our A. And then y equals 4 over x, it is a reciprocal graph. So we're looking for a graph where it has this kind of shape, or it could be the other way around, depending on whether it's positive or negative. So the only ones that have that shape is B and H, but to distinguish which one is which, notice how it's over 4 over x, it's not negative, all the values in that equation are positive. So the positive shape would be the red one that I've drawn over here, so it would be H. That would be our answer for that. Okay, so moving on. Move that away. Okay, so having a look at question 15, we got a bit of a proof question going on. So here it just wants us to prove that triangle ABE and triangle DCE are similar. So let's have a look at these two triangles. So I'm going to just highlight which ones we're focusing on. So it's trying to say that this triangle here is similar to, put in a different color, this triangle here. So let's have a look. First of all, let's look at how many marks it is. So this is a 3-mark question. So we're going to look for 3 succinct points to prove. Okay, so first thing that we can notice is that the angle AEB, which is here, and the angle DEC, which is here, are vertically opposite to each other. And we know from angle rules that vertically opposite angles are equal. So I'm going to write down AEB. Remember, put the hat on to show it's an angle that you're talking about. DEC. So AEB is equal to DEC. Because vertically opposite angles are equal. And then if we have a look at angle ABE and angle ECD, angles that are from the same point. So literally we know that they're not from the same point, but because we're trying to prove that they're both the same triangles, then angles from the same point, so ABE is equal to ECD, because angles from the same points of that shape are equal. So just to reiterate that, if we have a look, ABE, so this one here, and ECD, because it goes ABE and then ECD, so they are set technically from the same point. So angles from the same points, because they both cross that E, are equal. And then the last point is the fact that BAE and angle BDC, they literally, so BAE, so they both come from, so BAE and then BDC, because they're both coming from that B point. So let me just make note of that. So angles from the same point, so basically the same as the one above, are equal. So because of these 3 proofs, because remember it's 3 marks, therefore we can say that all angles are equal. So because all the angles on the triangle are equal, therefore they are similar. Okay, So then let's have a look at question 16. So having a look at question 16, it wants us to use algebra to prove that 0.136 recurring times 0.2 recurring is equal to 1 over 33. So let's have a look. So 0.136 recurring, we're going to say that's equal to x. So if we now multiply this by 10, then 1.36 recurring is equal to 10x, right? We've multiplied both sides by 10. Let's say if we now multiply this by 100, we would have 136.36 recurring is equal to 1000x. And so to work out what x is, what we would need to do is by taking away the value of 1000x from 10x, we're left with 990x. And so if we did that on the other side, you would do the 136.36 recurring, take away the 136, take away the 1.36 recurring. And by doing that, you've technically removed the recurring. So you don't even need your calculator to work that out. Because by removing the recurrings, because their recurring decimals are the same, then you're just left with doing 136 take away 1, which is 135. So now, because these are nicer numbers to work out what x is, we would do 135 over 990. And because we're trying to prove it as a fraction, don't use your calculator for this because your calculator is going to give you decimals. So then by working this out and simplifying it, we'd be left with 3 over 22. So then now that we have 3 over 22, we're now going to, so we've worked out that 0.136 recurring as a fraction is 3 over 22. So now we need to work out the 0.2 recurring as a fraction. So 0.2 recurring, we're going to make that equal to y. If we multiply that by 10, we would end up with 2.2 recurring is equal to 10y. And if we multiply that by 10 again, then 100y would be equal to 22.2 recurring. Take away the y's from each other, you'd end up with 90y is equal to, again, the recurrings have cancelled out. So now you've got 20. And then to work out what y is, you would do 20 over 90. Simplify that as a fraction. This one's nicer. You'd end up with 2 over 9. So now because these two decimals need to be multiplied by each other, we're going to do 3 over 22 times by 2 over 9. That would give you 6 over, so 22 times 9 in your calculator, 198. And then if we were to simplify this, we can do 198 divided by 6. That'll give you 33. And then 1 over 30. So that would be that answer. So the key point with this question is you basically want to make them equal to a letter. You want to multiply them so you've got a value for like 10 of x or 10 of y or something, and then 1000 x or 1000 y or 100 y. And the whole point is that the reason why you're doing this is because when you take them away from each other, you remove the recurrings, so it's easier to convert it into a fraction. Okay. So looking at question 17, this is a bit to do with area of a sector. So I've got a video of area of sector and arc length, and to do with area of a triangle equation half A B side C. So having a look at, by the way, that video is in the link above if you want to refresh your memory. But having a look at this particular question, so it says ONQ is a sector of a circle with a center O and a radius 11. So by knowing that the radius 11, then I know that this is 11. Remember, the distance from the center to the circumference is the radius. Okay, and then it says that A is a point on ON and B is a point on OQ, such that OAB, so that's made an equilateral triangle of 7 centimeters, which means that's 7, that's 7, that's 7, because equilateral triangle, all the sides are the same. So then it wants us to work out the area of the shaded region as a percentage of the area of the sector. So let's dissect this bit by bit. So first thing is we want to work out the area of the sector. And the equation of the area of the sector is basically the area of a triangle, pi r squared, times by the angle in that sector over 360. So because we know it's an equilateral triangle, we know that this angle is going to be 60 degrees. Because in equilateral triangles, all the angles are the same. So by knowing that, it's going to be pi times, my radius is 11, so pi times 11 squared times 60 over 360. Put that all into your calculator, but also leave it in terms of pi so it's more accurate for working it out. So you wouldn't even need your calculator. Oh, no, still use your calculator if you can. But when you use your calculator, multiply this together. Don't multiply the pi together. And then that would leave you with 121 over 6 pi centimeter squared. Then we're going to work out the area of a triangle. Remember using the equation half AB sine C, because we only use half base times height if it's a right angle triangle. And so by doing that, your area of triangle would be half times, so AB, remember the two lengths, so because they're all 7, so times 7 times 7, and then times sine 60. So then by, again, putting that into your calculator, you would end up with 21.21762239. And then to work out the percentage now of the shaded region. So we know the area of the triangle. It wants us to work out the area of the shaded region as a percentage. So what we need to do is we know the shaded region, if I zoom out, to work out the actual area of the shaded region, we would do the area of the sector, take away the area of the triangle. So that would give us the area of the shaded region, because we want it as a percentage of the area. That would all be over the area of the sector, which was 121 over 6 pi. And then obviously because it's percentage times by 100, put that all into your calculator and you should end up with an answer of, to the correct one decimal place, 66.5%. Okay, moving on to question 18. So question 18, it wants us to work out the exact value of x. So this is really understanding your fractional indices. So let's have a look. So looking at this, to find out 16 to the power of fifth, that's the same as saying, so we know that 16 is the same as saying 2 to the power of 4, right? So because of that, if we change the 16 to 2 to the power of 4 to the power of a fifth, that's multiplied by 2 to the x, and then we've got 8 to the power of 3 over 4. Again, 8 is the same as saying 2 to the power of a 3. So we're going to change the 8 to 2 to the power of 3. Okay, so now that we've got that, the next thing is we want to get rid of the brackets. So to do that in terms of indices, you need to multiply the powers. So 4 times the fifth would leave you with 4 over 5 times the 2x. And then 3 times 3/4 would leave you with an answer of 2 to the power of 9 over 4. So now we've got that. When we've got work out multiplying indices, so based on your indices laws, multiplying indices means you add up the powers. So because they all have a base number of 2, if we now look at the powers now, in terms of multiplying indices, you're adding the powers. So that would be 4 over 5 plus x is equal to 9 over 4. So then now to simplify this, we're going to bring the fractions to one side. So x is going to be equal to 9 over 4 minus 4 over 5. We want the denominators to be the same. So then doing that, we're going to multiply the whole first fraction by 5 and the second fraction by 5. So then that would be 45 over 20 minus 16 over 20. Take them away from each other. So you can either you can stick in the fractions into your calculator and just take away the fractions straight away, or you can just take away the numerators from each other. So I'll do it that way. So that's 29 over 20. So x equals 29 over 20. So because it wants the exact value, put it into your calculator and see if you end up with a decimal. And you should end up with the decimal of x is equal to 1.45. So that should be your answer. Okay, so we're going to move on to question 19. Okay, so question 19, it says we basically got this algebraic fraction again, but in this case it wants us to write it in the single fraction ax plus b over x squared minus 9, and so by doing that we would work out the answers of a and b. So let's do this bit by bit. So in this scenario, you basically want to make sure that they all have the same denominator. So by doing that, we're going to multiply all the fractions by x minus 3 and x plus 3. So the first one, the 2, would end up having the denominator this. So that one would just have that. The second one, if we had x plus 2, we now multiply it by x. So we're multiplying the top and the bottom. Got that on there. X plus 3. So the second one, if we have this and we're multiplying the top by x plus 3 and x minus 3, do the same with the bottom as well. You've got x minus 3 on the top and you've got x minus 3 on the bottom, so they would end up cancelling out, which is why the whole of the bottom one for the second fraction would be x plus 3, x minus 3, and then the top, the numerator, would just be that. Okay. And then it's going to be the same as the second one because it already has an x plus 3. Sorry, the second one, the third one, because it already has an x plus 3 at the denominator, it's going to end up cancelling out the same way, but I was just showing you why that is the case. So to make it easier, we're basically just going to only multiply the third one by x minus 3. And by doing that, you'd end up with x minus 6 times x minus 3. And remember, whatever you do to the top, whatever you do to the bottom with fractions. Okay, so now we've got this. As complicated as it looks, I promise you it will simplify to be nicer. Now, because they all have the same denominators, we can squish them all together. So that would be the 2 bracket x plus 3 minus x plus 2, x plus 3 minus x minus 6, x minus 3, all over x plus 3, x minus 3. Next thing now, we need to simplify and expand the brackets. So if we expand the first bracket, so expanding the first bracket first, multiply the two brackets together. So that would be x squared minus 3x plus 3x minus 9. Plus 3x and minus 3x are going to cancel out. So that's going to leave you with x squared minus 9. Now multiply that by the 2 on the outside, you'll end up with 2x squared minus 18. And then if we have a look at the second set of brackets, if we were to expand that, it would be minus x squared plus 2x plus 3x plus 6. But the plus 2x and 3x are going to add together to make 5x. So then that would be plus 5x plus 6. And then the second one would be minus x squared minus 6x minus 3x plus 18. Minus 3x minus 6x minus 3x would leave you with minus 9x. So it will be x squared minus 9x plus 18. Yeah. Okay, so now we've got all of this. If we now want to remove the brackets for the other two, you basically want to multiply everything by minus 1. So it will be minus x squared minus 5x minus 6x minus x squared. Just bring it closer. Plus 9x. Because you're multiplying that by minus 1. Minus 18. And that is all over the x plus 3 times x minus 3, which if we were to expand those brackets, you would again get x squared minus 9, like we worked out up here. So now that we have all this, we need to simplify by collecting like terms. So if I scroll down. Okay, so we're going to collect all the x squareds together. So we've got 2x squared minus x squared minus x squared, which would all cancel out to 0. Then we've got 5x, we've got minus 5x plus 9x. So minus 5x plus 9x would be 4x. Then we've got minus 18 minus 6 minus 18. So all those negatives would leave you with minus 42, and that is all over x squared minus 9. And then, because now if we have a look at the format they wanted to leave us in, our answer is basically the format that they wanted. We've got the denominator of x squared minus 9, and we've got a value for a and b. So having a look at that, our value of a is 4, and value for b is minus 42. Okay. So having a look at question 20. Question 20, we've got a nice quadratic graph, and it basically wants us to find the solutions of when the graph is equal to 0. So because the graph is initially equal to y, if it's equal to 0, then we're looking for the line y equals 0. And we know that y equals 0 is also known as the x-axis. So we're looking at where it would cross the x-axis. However, this graph that is initially drawn is very different to the equation here. If you have a look. For the first equation, we've got a minus 2x plus 3. For the second equation, we've got minus 3x minus 1. So in order to work this out, what we would need to do, so we've got x squared minus 3x minus 1 is equal to 0. And we've got x squared minus 2x minus 1. So what we're going to do, so we've got x squared minus 2x minus 3, sorry, is equal to y. So first of all, to make these two equations similar, what we can do is if we look at the one that we've been given in part A, if we were to now take away or add x to both sides, we would end up with x squared minus 2x minus 1 is equal to x. Okay, so far it's looking kind of similar because now both of the equations have x squared, both of them have minus 2x. However, we still got that minus 1 and we really need the plus 3. So then, to make it plus 3, you want to add 4 to both sides. And by doing that, you would end up with x squared minus 2x plus 3 is equal to x plus 4, because now we've added 4. So now that we know that, that basically means to work out the point of when x squared minus 3x minus 1 is equal to 0, that would be the same as having the x squared minus 2x plus 3 graph with also the graph y is equal to x plus 4 crossing it. So now we need to work out the coordinates of that. So if I draw a quick table to work out some values. So when x is 1, y is 5, x is 2, y is 6. So x is 3, y is 7, and then when x is 0, y is 4, x is minus 1, y is... Okay, so plotting them on quickly. So when x is 1, y is 5, 2, 6. So this is quite a nice graph. So when x is 2, y is 6, x is 3, y is 7, and it should end up looking like this. So now connect all the lines together. This is our graph for x plus 4. So now we are looking for the points where they cross. So if we now zoom in to have a look at them, so the first point there, if I remove the first point, the coordinates would be, so the x value looks like it is crossing 3.2, and the y value is crossing 7, roughly. And down here, the x value is crossing minus 0.3, The y value is crossing 3.7 roughly. Okay, so now that we have our coordinates, basically at that point, because it's now equal to 0, then it's when y is equal to 0. And if y is equal to 0, then we don't really care about the y coordinates, therefore just the x ones. And so the solutions when it's equal to 0 would be 3.2 and minus 0.3. Okay, and then looking at part B, so it says P is a point on the graph drawn, the actual one drawn, where x is equal to 2, so it wants us to estimate the gradient of the graph at point P. So having a look at this, when we know that x is equal to 2, so if we substitute in the values of when x is equal to 2, so y would be equal to 2 squared minus 2 times 2, because we substitute for x, plus 3. So that would be 4 minus 4 plus 3, which is not 0, which is 3. So we know when x is 2, y is equal to 3. So x is 2, y is equal to 3. So that's equal to point P. So point P, put it in a different color, would be here. And now to work out the gradient, we know how to work out gradients of straight lines. So imagine if a straight line is crossing there, we want to now pick a point on that graph, which is on this rough sketch of the straight line that we've drawn. So nicest point that I can think of is this one here. So if I now rub out the straight line so I'm more accurate. So this one crosses our kind of sketch of a straight line. And so we know gradient is changing y and changing x. So from the other point that I've drawn, the coordinates of that was 2.44. So then changing y would be 4 minus 3, because the y value here is 4 minus 3, and then changing x would be 2.4 minus 2. So that'll be 1 over 0.4. And if you put into your calculator 1 divided by 0.4, you should get an answer of 2.5. Okay, good. So moving on. So on to question 21, we've got 3 identical circles within this square. So it wants us to work out the area, sorry, not into the square, inside a rectangle, what looks like a square, but always read the question. So the area of the rectangle. So area of a rectangle is length times width. So we need to work out the length times width we need to work out the length and the width in order to work out the area of this rectangle. So to answer this question, what we can see is it's given us that the radius of the circle is 24. So that means the diameter would be 48 and the diameter of this one would be 48. And because we know that the two circles, they touch nicely and they both like kind of cross the center, for the length, we've worked out 48 plus 48, which would be 96. So we've worked out that one, brill. But now to work out the width, it's slightly different because notice how they slightly overlap. So we can't just add like what we did before. So what you're going to need to do is you would need to work out that from there to there is the radius as well. So that would be 24. And from here to here is also the radius, which is 24. However, we need to work out from this overlapping gap and up to this overlapping gap. So how we would do that is we can form a triangle in this situation. So we're going to connect the three centers and form a triangle. Now we've got this triangle, we're going to make it a right angle triangle. Why am I saying that? Because now that we've made it into a right angle triangle, to work out what this length is here, which I'm going to put in a different color of blue, we know that this length would be the same as that length. So if we work out the blue length, we can work out the missing length. And how we can do that is Pythagoras theorem. So if we know that we've got 24, then this diagonal part here would be 48 because we can see the two radiuses connecting nicely. So then recap, Pythagoras is a squared plus b squared is equal to c squared. So this length here would be either our a or b. We'll call it b for this case. So our a is 24 squared plus b squared is equal to c squared, which is 48, because 48 is the hypotenuse. Remember, c has to be the hypotenuse, aka the length opposite the right angle, which I have a video up above to refresh your memory on that. So then, if you use your calculator to work that out, you're going to end up doing b squared is equal to 48 squared minus 24 squared. Put that all into your calculator, you would get b squared as 1,728. Square root that to work out what b is, you would end up with 24 root 3. So 24 root 3, because again, we're trying to keep it as accurate as possible to make our answer as accurate as possible. So 24 root 3 is that space. So then we need to add up the 24, the 24, and the 24 root 3 to work out the whole width. So it will be 24 root 3. Because we have two lots of 24, add them together will be 48. So that plus 48 multiplied by, remember, length times width. So this was our width, and then times the length, which was 96. Put that into your calculator, you should end up with an answer of 8,598.645061 millimeters squared. And then because we want it to three significant figures would round our answer to 8,600 millimeters squared. Three significant figures. Okay? Alright, good. So three significant figures would not be that. Three significant figures would be, because remember, three significant figures is like your total numbers. So that would be 859. Yeah, no, it would end up being 8599 if you rounded it to one decimal place. However, this is four significant figures. So to make it to three significant figures, it would be that. Okay, so moving on to question 2. So in question 2, we've got a sequence. So this could be either an arithmetic sequence or a quadratic sequence. So we can only tell as we go along. And how you can tell is write out the numbers. So with sequences, the first step is you want to work out the difference between all numbers in the sequence. So it'll be 7, 11, 15, 19. So, because they're not all the same, I know this is going to be a quadratic sequence. So with quadratic sequences, you want to work out the difference again, and you should get the same number. So now we've got 4, 4, 4, 4. So because in a quadratic sequence, your first term is an squared, this 4 is going to be equal to an squared, right? So in order to work out what that is, if we divide 4 by 2, we end up with 2, so it will be 2n squared. So whenever you worked out your difference, always then divide it by 2. That gives you the number in front of n squared. If the difference was 2, then you have nothing in front of the n squared, it would just be n squared. So now we know the first term is 2n squared. And then the next step is you want to work out the first, the second, and the third term for 2n squared. So aka when n is equal to 1, 2, and 3. So when n is equal to 1, you'll get an answer of 1 squared times 2, which is 2. When n is equal to 2, you would get 8. And when n is equal to 3, you would get 18. So because the numbers that we have in our sequence are 4, 11, and 22, if we work out the difference between all these numbers, you would end up with 2, 3, and 4. So we've still got a difference of 1. So working out the difference between them, you got a difference of 1, which means it's going to be n. So then working out the differences again gives you what your middle part, your bn is. But because it's just 1, it's just going to be n. So far we've got 2n squared plus n plus c. So to work out what the plus c is, what you can do is you can substitute. So when n is 1, so n 1, 2, 3, 4. When n is 1, the answer should be 4. So we can substitute n is equal to 1 into what we have so far. That should leave you with 2 plus 1 plus c is equal to 4. 3 plus c is equal to 4. So c is equal to 1. And then just double check you're right. Substitute that same thing for when n is 2. So when n is 2, you would get 8 plus 1 plus c is equal to 11. So it would be, 8 plus 2, because when n is 2, plus c is equal to 11. So 10 plus c is equal to 11. So c would be equal to 1. And so because both of the c values are 1, you know your equation is right so far. So then the final answer would be 2n squared plus n plus c plus 1. Because our c value is 1. Okay, and then having a look at question 23. Okay, so with question 23, it's given us an equation of a circle. So I'm just going to sketch, love to sketch with answering questions. So this is our circle, roughly. So because with equation of a circle, your x's and your y tells you where the center is going to be. So because there's no number with that, I know my center is 0, 0. And what it's equal to is usually equal to the radius squared. So square root of 4 is 2. So I know my radius for my circle is 2. So across there, 2, 2, minus 2, minus 2. And then it's given me a point P, which is 3 over 2, root 7 over 2. So that would be somewhere, I'm just going to estimate where that would be. So that would be about here. I'll just call it point P. Again, it doesn't really matter where, like the accuracy of your sketch, just a rough sketch. So what we're going to do is work out the equation of the tangent. So the reason why I have sketched it out is because it will make it make sense. So a tangent, when it comes to circles, is a line that is perpendicular to the equation of the circle. It's perpendicular. It's a line that it touches the circle. So if that's our radius, that's our tangent. So long story short, if we now work out the gradient of the circle at point P, so work out the gradient at point P, because remember point P is on the circle, if we work out the negative reciprocal of that, we can therefore work out the gradient of the tangent, and that will help us to work out the equation. So let me stop waffling and actually work this out. So to work out the gradient at point P, remember, gradient is changing y by changing x, so you want 2 points. So because we know definitely one of the points in the circle is the center, which was 0, 0, we are going to work out the gradient using the center and the point P. So looking at the y values, it's changing y minus changing x, so that will be root 7 over 2 minus 0, and then you're changing your x's, so 3 over 2 minus 0. Having a look at that, the minus zeros are going to end up cancelling. So we have root 7 over 2 divided by 3 over 2. Remember, when it comes to dividing fractions, you end up timesing if you flip it. So that would be times 2 over 3. That would be 2 root 7 over 6. So, and then that divided by, so cancel that, divide by 2. That would be root 7 over 3. Or another way of noticing is because you've got 2 at the top, 2 at the bottom, that would cancel out and leave you root 7 over 3. So that's the gradient of point P on the circle. On the tangent now, negative reciprocal means we're going to flip it. So that would be 3 over root 7, and you stick a negative in front. So now we've got the gradient for the tangent. Remember, tangent is a straight line, right? And we know the equation for a straight line is y equals mx plus c. M is our gradient, which is minus over root 7, minus 3 over root 7. So now we need to work out the plus c. We don't know what the plus c is. So now to work out the plus c, because we know point P is on the tangent, we're going to substitute the x and y values of point P. So that would be, the y value is root 7 over 2. That's going to be equal to minus 3 over root 7. And then the x value of P was 3 over 2 plus c. And by solving this to work out what, we can work out what c is. So let's solve. So scroll down for more space. So root 7 over 2 is equal to minus 9 over 2 root 7 plus c. Collect everything on the same side. So that would give you my root 7 over 2 plus 9 over 2 root 7 equals c. So in terms of now working out what this is, you can literally stick this into your calculator and then you can change it on the settings of your calculator to give you a surd form. But if you don't know how to do that, another way is we can rationalize these two surds. So rationalizing the two surds, that would leave us with, so for the first one, that would be root 7 over 2. That's not going to change. But the second one, to rationalize, we're going to times the top and the bottom by root 7. And by doing that, you'd end up with 9 root 7 over, so root 7 times root 7 is 7. 7 times 2 is 14 equals c. We're going to now change the first fraction to have the same denominator of 14, so times top and bottom by 7. That's going to leave you with 7 root 7 over 14 plus 9 root 7 over 14 is equal to c. 9 root 7 plus 7 root 7 would leave you with an answer of 16 root 7 over 14 equals c. We can simplify this into, so divide top and bottom by 2, which would be 8 root 7 over 7 is equal to c. So the final answer for the equation, just looking at the equation of the tangent, by the way, the gradient of the tangent, we want to rationalize that as well. So times both 3 over root 7 by root 7. Rationalize just means you make surds nicer so there's no surd at the bottom of the fraction. So that would be minus 3 root 7 over 7. Okay, so then the final answer would be y is equal to minus 3 root 7 over 7 x plus 8 root 7 over 7. And guys, we finished the past paper. Thank you for watching. I hope this was useful.